To begin with, the definition of perpendicular lines, contrary to what you might think, is actually two lines that meet to form congruent adjacent angles. While it is true that perpendicular lines form 90-degree angles, that will be a theorem which we will prove later on. Remember, the definition is that it forms congruent adjacent angles. A relation, mathematically speaking, is a connection or a mapping between two sets. We can relate two things by putting the relation in between them. For example, if m and n are lines, this would be the relation m is perpendicular to n. There are a number of properties that might hold for certain relations. The first is the reflexive property, which is to say that everything is related to itself. The equals relation has the reflexive property. All numbers are equal to themselves. There is also the symmetric property, which is to say that if two items are related in one direction, they are also related in the reverse direction. Coming back to the perpendicular relation, if two lines are perpendicular, for instance m perpendicular to n, then it's also true that the reverse holds, that is, n is perpendicular to m. Lastly, we have the transitive property. The transitive property states that if two items are related to each other, and that the second item is related to a third item, then the first is related to the third. An example of the transitive property would be the parallel relation. If m is parallel to n, and n is parallel to l, it follows that m is parallel to l. Our first theorem is that if two lines are perpendicular, then they meet to form right angles. Take a moment and think about it. Draw the picture. Convince yourself that this is the case. You might have drawn a picture that looks a little bit like this. Remember, a perpendicular line by definition only forms congruent angles. The key to this proof is showing that those congruent angles must measure 90 degrees. Our next theorem is that if two lines intersect, then the vertical angles formed are congruent. Remember that vertical angles are opposites when two lines cross. Here I have notated the vertical angles as congruent. We will prove this in class. The third theorem for this section is that in a plane there is exactly one line perpendicular to a line at a given point on that line. So take a line and consider any point on that line. This theorem guarantees that there is only one line which is perpendicular through that point. It might help to imagine another line which was somehow magically perpendicular as well, and you could see very visually that it doesn't quite work out. The new line doesn't split it into four congruent angles. For our last theorem, we have that the perpendicular bisector of any line segment is unique. Recall how to construct the perpendicular bisector. First, draw any line segment AB. Draw a circular arc with a center at A, and with the same radius, draw a circular arc with a center at B. So long as each of those circular arcs has a radius that is more than half the length of AB, you will be able to construct the perpendicular bisector by drawing a line through the 2 points of intersection. This is a unique line, and we will prove this together in class.